This is a spec for the second, I guess we could call it derivatives too, but it's specifically going to be about the power rule, which is essentially the first, I guess, rule that people learn when they start taking derivatives once they get past the definition of the derivatives. And we're essentially just going to throw out a bunch of polynomials, and the students are going to use the power rule to find their derivative. So we could write f of x is equal to, and you could put, just kind of an nth degree polynomial here. You could write crazy things like, 4x to the ninth plus 7x squared minus, and actually it doesn't even have to be kind of the traditional polynomial. We can even have negative exponents here. Actually, we should have negative exponents. And so, I'll just put a negative 2x plus 3x to the negative 1, something like that. You don't always have to be like this. It could just be a simple x squared. It could be all positive. We could change it up. We don't always want to put negative exponents there. But in general, when the first time, and of course we'll say this is f of x, find, or we could just write f prime of x is equal to question mark, or essentially what's the derivative of this. And so you say, so the first hint, the derivative, so the derivative d dx of a x to the n, we're essentially just telling people the power rule. The derivative of a x to the n is equal to n times a x to the n minus 1. So that's just a refresher of the power rule, if they can kind of parse that out. The next hint, so f prime of x is equal to, or we can actually, this will probably be the best thing to do. So we break it up. So the derivative d of x of 4x to the ninth is equal to 9 times 4x to the 9 minus 1, which is equal to 36x to the eighth. Click hint again. You get the derivative of 7x squared is equal to, same thing, 2 times 7. And you could even color code it if you make that. Although I wouldn't worry too much about color coding it right now. Keep it fairly straightforward. 2 times 7, x to the 2 minus 1 is equal to 14x. That's just 14x. And then you say the derivative of negative 2x. So you have to do it for however many terms. You don't have to get too fancy. Even if you only have up to 3 terms, that's really going to hit the point. You could have 1, 2, or 3 terms in every problem. You don't have to do 4, but we could do 4 if we like. So the derivative of this is going to be equal to, and we could even write x to the 1 there to make it explicit, is equal to 1 times negative 2 times x to the 1 minus 1, which is equal to negative 2. And then finally, we have the derivative of 3, sorry, we have the derivative of 3x to the negative 1. We say that is equal to negative 1 times 3 times x to the negative 1 minus 1, which is equal to negative 3x to the negative 2. And then finally, so we'll say f prime of x is equal to the derivative, just so they're used to the notation, of 4x to the ninth plus 7x squared. So they're used to this operator notation, minus 2x plus 3x to the negative 1, which is equal to, and we just write all of this, 36x to the eighth plus 14x minus 2 minus 3x to the negative minus 3x to the negative 2. And so in general, we'd obviously want to put this as one of the choices. So I could copy and paste that. If you let me just copy and paste it just to visualize it a little bit better. So copy, and then let me paste it. So, that's why you don't see the whole answer there, but that'll be one of the choices. It goes off the screen, but you get the idea. And then the other choices, it'll be good to put as possible incorrect answers, stuff where someone kind of confuses the power rule a little bit. Maybe they go the other way. Maybe they increment the exponents, or maybe they decrement the exponents, but they forget to multiply by it. Or maybe they multiply and they forget to decrement the exponent there. So those should be all the combinations for the incorrect answers. And then we could put some random things. But really, if we just mess around this in an incorrect way, we should get the things here. And especially with negative exponents, sometimes when people think they're decrementing it, they actually increment it. So sometimes if they're taking the derivative of 3x to the minus 3, they're sometimes tempted to say this is negative 3 times 3x to the minus 2, even though it should be x to the minus 4. I'm guilty of that sometimes as well, that you have to decrement this. So make that a possible error here, where it's the correct answer, except maybe they mess up with the negative exponent if there is one. So in general, we're just going to keep giving polynomials, and we can play with the notation just so that the student gets exposed to the different ways that you can write this stuff. So you wrote f of x. We could have also written, you could put some simple ones in there. You could say, look, y is equal to 4x squared minus 5. And then we could say dy dx is equal to question mark. So different notation. We could have also written this. And it's good to switch it up. We could also, instead of writing dy dx is equal to question mark, we could write y prime is equal to question mark. Or if we wrote this as f of x notation, we could have written f prime. Or, well, there's a bunch of different, well, you could either f of x, or if you have it as explicitly y is equal to, that's dy dx, or y prime. And if we really want to mix it up, we can even show, look, it doesn't always have to be in terms of y. It could be a is equal to b cubed minus c. Well, I don't want to actually get too abstract just yet. So minus 3. And then we could ask dA dB is equal to question mark. Just so they understand we're taking the derivative of a with respect to b. And of course, in this case, it would be 3b squared. So hopefully that gives a sense. This should be a pretty straightforward module. We just want to keep the coefficients and the exponents random, and we should be able to give people a lot of practice with the power rule.